need to get information from the system about the system itself, about devices in the system, or about system information from the kernel, we can use the WMI interface, the Windows Management Instrumentation Interface. It's the Microsoft implementation of web-based enterprise management, and it uses the Common Information Model to create objects that attach to and describe system resources, such as devices, programs that are running, network resources, etc. The base command to retrieve this information and gather up these objects is called getWMIObject. To save yourself typing, you can use GWMI, which is an alias for that. To retrieve an object, you need to tell getWMIObject what class of object you wish to retrieve, and it will go ahead and build you an object and populate the properties. The trick with getWMIObject is knowing what class to use. There is a parameter that you can give getWMIObject, -list. If you just do -list, you'll get a list of all the currently loaded WMI objects in the system, which is a very long list, and trying to find what you want in that list is not very feasible. So the best thing to do is to search the list. Searching the list is by putting a string after the list parameter, and you're allowed to use the star wildcard in that string. The example on the slide, GWI-list star adapter star, would find all of the class names or object type names that have the word adapter in them. Why would we search for that? Well, we know that our network interfaces are connected through what Microsoft calls network adapters, our network interfaces. So if I wanted to know what classes of WMI objects or types of WMI objects I can create and use to do with networking, I would do my getWMIObject -list, and I could try star adapter star. If I did that and didn't get something I wanted, I could try star network star, although I'm probably going to get a great many objects that aren't relevant to me. Let's suppose that our task is to find out our IP address. So let's start by checking our adapter object types and see if there's one there that might have the data we want. In our output list, we have a few different things. The name of the classes is in the left-hand column, and that's what we're going to focus on here. There are two types of names that will show up, ones that start with Win32 and ones that start with CIM. CIM is the Common Information Model. It is an industry standard. It's a standard that describes how information is structured and represented in your system, and it's designed to make it easy to write portable applications that work on multiple systems that have to access system resource data. WMI is the Microsoft specific version of that. It's been around quite some time. Those are the ones that start with Win32. When you have a Win32 object, you have to handle it a little differently in PowerShell than when you have a CIM object. It has different methods and different ways of connecting those objects together. To return to our list, we were looking for information that might help us find an IP address. Looking at this list, we can see that many of these are related to performance data. So in other words, this is about current traffic levels and characteristics of running network connections and interfaces. That's not what we're looking for. We have a Win32 network adapter setting, a Win32 network adapter, and a Win32 network adapter configuration type. Those are three different types of type WMI. And we have a SIM network adapter. Note that we only have a SIM network adapter. We don't have a SIM network adapter setting or SIM network adapter configuration. This is why, even though the WMI interface is deprecated now by Microsoft, it's not supposed to have a future, we're not supposed to be using it anymore, we're supposed to be using CIM. This is why WMI is still very widely used, because many things that are in WMI are not available in CIM yet from Microsoft. That doesn't mean the CIM standards don't provide for it. It just means Microsoft hasn't implemented it there yet. It is common to see WMI being used simply because it's been around longer in the Microsoft world. To retrieve one of these objects, we do our getWMI object, and we can optionally put in -class, and we give it the name of the class we want. If we think the network adapter objects might have the IP address we were looking for, we could go ahead and retrieve that. And we're going to find a long list. If we were to take that and pipe it to a format table, FT is an alias for format table, we'll find it's a long list because there are multiple objects. Now we don't see our IP addresses in the default list of properties that are being displayed, but we learned some time ago that just because we see a default list of properties, that doesn't mean those are all the properties that are in those objects. It may be, but it's unlikely. The way to explore the objects for our purposes would be either to format a list of all properties to see the properties and their values. And if we do that, we get a very long list indeed, because there's a separate list for each network object. And if we just visually examine, we can tell where one starts and ends because there's a blank line between objects. We could look through here, and what we will find is there are no IP addresses here. Does that mean these objects don't have the IP address? Well, it means they don't have them as a property. But recall, sometimes when we have an object, the way we retrieve data from it is by running a method, not by just looking at a property. So we might actually also wish to pipe these to getMember to see what kind of methods are available to us. And we'll find there aren't very many methods, and we already know the properties don't give us what we want. So this is not going to be the right object type or class to give us our IP address. We would now return back to our searched list, which is a long way back in my scroll. So I will just run that again. Search for adapter types. There's the other one. So if I were to get WMI object, Win32 network adapter configuration, and you'll notice this time I didn't put in -class because putting in -class is optional. You'll see that we have a list, again, of all of our devices. And this time, when we have a device that has IP addresses, whether it's IPv4 or IPv6, it is included. So we've discovered that if we need to do work in a PowerShell script with an IP address, these are the object types we need to look at.